Okay, if we look at problem 2 of the homework, a magnesium undergoes a single replacement reaction with hydrochloric acid, and they want us to write the balanced equation. So we're going to have magnesium, let me just cover this up. So we focus on the one we're working. Magnesium is an element, solid, undergoes a single replacement reaction. So magnesium is one reactant, hydrochloric acid is the other, HCl, I would give you that, I would give you this one. And then single replacement, magnesium is going to replace the hydrogen in the acid, and you're going to get hydrogen gas. Plus the magnesium goes with the chlorine. So remember, when we're mixing magnesium with Cl, we are going to first write the symbols for each element and the compound, and then we're going to look at its charge. This is in group 2, so it's +2, and this is -1. And so we have to cross the 2 here and the 1 there, and we don't write the 1. So there we go. Magnesium chloride is soluble. So look in your list. And is it balanced? No. I have 2 chlorine, 2 hydrogen, so if I put a 2 here, that then will be balanced. Put a 2 there, and then that's it. So it's balanced. So we did the first part. Now we're going to use the balanced. All stoichiometry starts with a balanced chemical equation. And we're going to ask how many grams of the hydrogen gas will be produced from 3 grams. So let's see what we're given. We're given 3 grams of magnesium and 4 grams of hydrochloric acid. And so I'm given 3 grams here and 4 grams of this. So is this a limiting reactant problem? And you would tell me yes, because I gave you more than one amount. I gave you amounts for more than one reactant. So you don't know if all 3 grams are going to be used, or am I going to use all 4 grams of hydrochloric acid and have this left over? So we have to figure out which one do we run out of first. So if all 3 grams react, how much hydrogen will I produce? If all 4 grams react, how much hydrogen will I produce? And whichever reactant produces the least amount of product is the limiting reactant. And here, we've got to focus on our question, and our question that they're wanting us to find out is the mass of hydrogen gas. So, question mark, and they want the mass. The unit for mass is grams. Okay. So this is my flow chart. So if we go back here, let me just do it down here. If we go back to this, grams of A to moles of A using the molar mass of magnesium, and then from moles of A to moles of the product to grams of the product, because it asked me for grams. So I want to go from the grams I'm given of A to the grams I produce of B. Once I do that, I get an amount of hydrogen gas. Then I start a new problem and do 4 grams of hydrochloric acid to moles of hydrochloric acid, and I relate it to hydrogen and get grams of hydrogen gas. Whichever of these produce least hydrogen, that's the limiting, and that's the one you need to keep, because we can't base the amount of product on the excess reagent. So here we go. So we have to start with 4 moles, or I guess I could have started with 3, but I'm going to start with 4 moles, 4 grams of hydrochloric acid. And if we follow my flow chart, grams of hydrochloric acid to moles of hydrochloric acid, so 1 mole of hydrochloric acid weighs, and we'll do the molar mass here, it's going to be 1.01 plus 35.45, and so we see that we're going to get 36.46 grams of HCl. And our units cancel, and now I'm in moles of hydrochloric acid. How do I relate acid to the product? Through the mole ratio. So 1 mole of hydrogen to 2 moles of HCl. The unit I'm moving to goes on top. 1 mole of hydrogen gas to 2 moles of HCl. Now I'm here in my flow chart. I know the moles of hydrogen. I just need to get to the grams of hydrogen, and I get that through the molar mass. And hydrogen is 2 times 0.101 grams of HCl in 1 mole. Oh, what am I doing? Hydrogen. Sorry, that's hydrogen. 1 mole of hydrogen. Okay, so there we go. This is hydrogen. So if we get the calculator, calculator, that's not our answer, that's from another problem. We're going to take our 4 grams divided by 36.4. Oops, that should be 46. 36.46. And then this is also in the denominator, so I have to put equal, and then we have to divide by 2. Anything in the denominator we divide, anything in the numerator we multiply. Divided by 2 times 2.02. And that gives me, let me get out of scientific into floating, that gives me 0.11 grams of hydrogen. Notice I have 3 significant digits, so I really need 3, so I need to round to the 3rd digit. There's an 8 there, so that's going to round the 0 to a 1, so it's going to be 0.111 grams. So the answer for this one is 0.111 grams of hydrogen. So if all of the hydrochloric acid is used up, it will make 0.111 grams of hydrogen. Now we have to check the other reactant, which is magnesium. So 3 grams of magnesium. Magnesium is easy because it's an element. So the molar mass or atomic weight of magnesium is 24. Oh, put it in the wrong spot. 1 mole of magnesium weighs 24.31 grams. And that's how I knew I set it up wrong. My grams need to cancel. So now I'm in moles of magnesium. Moles of magnesium to moles of hydrogen. That's the mole ratio. Hydrogen's 1, magnesium's 1, so that's 1 to 1. 1 mole of hydrogen is produced for every 1 mole of magnesium that reacts. And now I just need to get to grams of hydrogen, so multiply by the molar mass, which is 2.02 grams of hydrogen and 1 mole of hydrogen. And again, we use our calculator. So we take the 3 divided by the 24.31. Don't have to worry about multiplying by 1, and we multiply by 2.02. And we get 0.249 grams of hydrogen. So now let's see how we interpret this. If all of the hydrochloric acid is used up, I make this much hydrogen. If all of the magnesium is used, I make more hydrogen. I'm going to run out of one of these first, and it'll be the one that produced the least product. So this is the true answer. So this is my answer. That is the answer. That's my claim. this is nonsense. I'm not going to make that because I'm going to run out of HCl before I run out of HCl when I get this much hydrogen produced. So if I have more than that, I've already run out of this. I'm not going to be able to make that. That tells me that HCl is limiting and that magnesium is in excess. That's what it tells me. So we're done, because in doing this work to figure out the limiting, I've already answered my question. That's why I like this method. It makes you do the setup twice, but at the end of it you know your answer already. You don't have anything else to figure out. And it said identify the limiting reactant. Well, we already did. So we just have to say HCl is the limiting reactant. And we can say because it produced the least amount of hydrogen. And then I can use my data to back up my claim. That grams from HCl is less than 0.249 grams of hydrogen from magnesium. That's my justification. HCl is limiting. Why? Because it produced the least amount of hydrogen. And then here's my data to prove it. 0.111 grams of hydrogen were produced. Why did I say HCl? Some hydrogen. That many grams of hydrogen. Were produced from HCl. This many grams of hydrogen from magnesium. And this is smaller. That's the least amount. There's my justification.